This is Module 11, Section 6.4, factoring ax squared plus bx plus c trinomials. When factoring the more difficult type of trinomials, ax squared plus bx plus c, several different methods can be taught to students. Our text offers two methods, the trial and error method, which is Section 6.3 in our text, and the grouping method, Section 6.4. We will only discuss the grouping method as it will work for all factorable trinomials and minimizes guesswork on the student's part. Also, note that the grouping method will work for the easier types of trinomials too, x squared plus bx plus c, as long as you recognize that a equals 1. Here's how the factoring by grouping method works. Your first step is to write the equation in ax squared plus bx plus c form if it's not already written like that. Second step, find the product a times c. Find two factors of that product, a times c, which add to give you b. Then you're going to rewrite the middle bx term in the original expression as a sum of the factors found in step 3. At this point, the problem will now have 4 terms, so you're set up perfectly to factor by grouping as we did before. Okay, so let's just jump right in and do a bunch of examples. This is an ax squared plus bx plus c trinomial. The way you recognize it as such is notice that the coefficient or the number in front of the squared term is something other than 1. Although everything we're going to do here using this method will also work for the easier trinomials where a is 1. All right, so make sure it's in descending power order. We've got 6x squared plus 7x plus 2. So you can see by direct comparison that a, which is the coefficient of your squared term, is positive 6 in this example. B is positive 7, and c is positive 2. Okay. So our next step, after we make sure we're in ax squared plus bx plus c form, is to find the product a times c. So a times c in this example would be 6 times positive 2, make sure you carry your sign, which gives us a positive 12. All right, once you get the product a times c, we're now going to take that value and find factors of positive 12 that when we add them instead of multiply them give us our middle term or our b term, which in this case is positive 7. Now this might seem very similar to what we did for the easier trinomials, x squared plus bx plus c, but notice it's a little different. Before, when we were doing the easier trinomials, we were finding factors of just c. Here, we're finding a times c first and then finding factors of that. Okay, so that's one difference here. Before, we were just finding factors of c. Now we're finding factors of the product a times c. Okay, so factors of 12. There is several examples that we can look at. There's 1 times 12. There's 2 times 6. There's 3 times 4, and then there's the double negatives of all those as well. Now our goal is to find a pair there that when you add instead of multiply, give you a positive 7. And notice that this possibility right here is what we want. 3 times 4 is positive 12, but 3 plus 4 is positive 7. So what we're going to do with those two factors, again, is different from what we did before. For the easier trinomials, when we found those factors, we just put those in our groups and we had our answer. But notice that's not what we do with them here. What we do here is, this is step number 4, we're going to rewrite the middle bx term in the original expression as the sum of the factors we just found. In other words, if you come back to the original problem, we're going to take the original problem and we're going to rewrite that middle term. And we're going to rewrite it using the factors that we just found, which was a positive 3 and a positive 4. But notice that it's not just a plus 7 for that middle term, it's a plus 7x. So in addition to using those factors, you have to attach an x to those because we want the problem to be the same problem, just written a different way. And you would agree with me that 3x plus 4x is the same as 7x if you combine like terms. The first term in the trinomial does not change, and the last term in the trinomial does not change. You just rewrite those. So now we have 6x squared plus 3x plus 4x plus 2, which is the same as 6x squared plus 7x plus 2. It's just written another way. Now, though, after we rewrite that middle term, we no longer have 3 terms, we now have 4. And so with 4 terms, we talk about factoring by grouping. So group in pairs, okay? Look for common factors in each group. So in this first group, we can pull out a 3 and pull out an x. That leaves us with 2x plus 1. Out of the second group, we can pull out a 2, and that leaves us with 2x plus 1. Our groups now match, just like with any factoring by grouping problem. So now we have the group 2x plus 1 times the group 3x plus 2, and that is the factored form of our original trinomial, 6x squared plus 7x plus 2. All right. Let's do some more examples. Let's look at 15x squared plus 17x plus 4. Again, you're going to recognize that this is not one of the easier trinomials because there's a number in front of the squared term other than 1. So your first step is to multiply a times c, which is simply the first number times the last number in the problem written in descending order. So you've got positive 15 times positive 4 gives us, if you do that multiplication step, a positive 60. Your next step is to find factors of positive 60 that when you add give you your middle term, which is a positive 17. Now 60 has several different factors. There's several different ways we could break those down. One of the ways to break down 60, though, is positive 1 times positive 60, or 2 times 30, 3 times 20. Now at this point you might look at that and you might say, oh, that's probably it, because I can combine 3 and 20 to get a 17. That's true, but in order to get that to work, you would have to make 3 be negative, because negative 3 plus 20 is 17. But that doesn't work for the multiplication step, because negative 3 times 20 is negative 60, and this is a positive 60. So on the surface, it looks like some combination of 3 and 20 should work, but in this case, it does not. So looking for more factors, another possibility would be 5 and 12. 5 times 12 is 60, and at the same time, 5 plus 12 is 17. So our two factors are positive 5 and positive 12. Now what we're going to do with those is we're going to rewrite that middle term. So we now have 15x squared plus 5x plus 12x plus 4. Notice we didn't change the first term or the last term. We just rewrote the middle term. Double check. Is 5x plus 12x 17x? And the answer is yes. So group in pairs and factor out the greatest common factor. 15x squared plus 5x, there is a common factor of 5 and a common factor of x. You can pull those out. 15 divided by 5 is 3. We had 2 x's. We pulled 1 out. We're left with 1. plus 5x divided by 5x leaves us with a plus 1. Okay, out of that second group, we can pull out a positive 4. And that leaves us with 3x plus 1. Notice our groups now match. This is factoring by grouping. So factor out the group and multiply that to the group of what's left, 5x plus 4. As always, if you're unsure of your work, you can multiply those out using FOIL method or distributive property or whatever multiplication method you like to check your answer to make sure you get the original problem. All right, let's look at this problem here. Again, this is ax squared plus bx plus c. So our first step is to multiply together our a times c, which in this example is positive 9 times negative 8. Make sure you carry the sign. 9 times negative 8 is negative 72. What we want to do with that is we want to find factors of negative 72 that will then add to give us our middle term, which is negative 6. So negative 72 does have several different types of factors. You could start down the list if you wanted to, but what might come up immediately to you is 7 times 8, which is for 72, I'm sorry, that's not right. Try that again. For 72, you might immediately think of 9 times 8. Of course, one of those has to be negative. But notice that if the 9 is negative, negative 9 times 8, which is negative 72, if you add those, negative 9 plus 8, that's negative 1. That does not work. And if you put the negative on the other factor, 9 times negative 8, and you added those together, 9 plus negative 8 is a positive 1. That also obviously is not negative 6. So as you run through the possible factors of those, eventually you should come to 12 and 6. Now, 12 times 6 does give you 72, but this is a negative 72, so we know that one of those two factors needs to be negative. Of those two, we want the one that when you add gives you negative 6. And you would agree with me that that possibility would be right here. Negative 12 plus 6 is negative 6. So what do we do with those factors? We come back to the original problem. We're going to rewrite that middle term. So we've got 9x squared out front and minus 8 on the end. First and last term don't change. The middle term is going to be rewritten as minus 12x plus 6x. Now at this point, let me point out that you, when you were doing this problem, might have written the positive 6 first and the negative 12 last. And the question often comes up in traditional classes, well, is that okay? Could I write plus 6x minus 12x and still get the same answer? And the answer is yes, you will get the same answer in the end. Okay? Your steps are going to be a little bit different because you'll have different groups when you do factoring by grouping, but in the end, your factored out groups will be exactly the same. So order is not important as long as you have the correct two factors. All right, so at this point, we're going to factor by grouping, so group in pairs. Out of this first group, we can pull a 3 and an x, which leaves us with 3x minus 4. Plus, out of the second group, we can pull out a positive 2, and that leaves us with 3x minus 4 there as well. Our groups match, and we've got 3x minus 4 if we factor out the group, multiplied to the group of what's left, 3x plus 2. And there is the factored form of 9x squared minus 6x minus 8. All right, let's look at these two examples. First step, you want to multiply the first coefficient to the last term in the problem after you're sure that everything's in descending power order. That's going to give us a negative 24. We're now interested in factors of negative 24 that when we add them give us negative 10, our middle term. So again, several different ways you can break down negative 24. There's 1 and 24 with either the 1 or the 24 negative. You can see that when you add those together, though, neither of those are going to be negative 10. There is 2 and 12, and again, one of the two, that should be a 12 there, one of the two should be negative. Okay? But when you add those, you can see that although one of them doesn't give you negative 10, the other one does. Okay? Here, 2 times negative 12 is negative 24, and when you add that pair, 2 plus negative 12 is negative 10. So there's our two factors. Come over here to the middle term and rewrite that middle term. We've got 3x squared plus 2x plus negative 12x minus 8. Or you can write minus 12x there if you want. The only thing you have to remember, if you write a subtraction instead of adding a negative, when you put in your groups, you have to include that negative in your group. Okay, so group in pairs. Out of that first group, we're going to pull out an x, which leaves us with 3x plus 2. Now our second group, notice, is a negative leading term, so we want to factor out a negative something. So I know that I'm going to pull out a negative. The greatest common factor there is a 4. So when you pull out a negative 4, not only are you pulling out a 4, but you're also changing the sign of each term in that group. So negative 12 divided by negative 4 is a positive 3, and then of course you've got that x attached. And minus 8 divided by minus 4 is a positive 2. Groups match. So you've got 3x plus 2 and x minus 4 as your final answer. Okay, next example. 4x squared minus x minus 3. Multiply your first and your last term together, the numerical coefficients. That gives us minus 12. We want factors of minus 12 that add to give us our middle term, which in this case, remember there's an understood 1 here. Okay, so we want them to add to give us a negative 1. Negative 12, that could be 1 times negative 12 or negative 1 times 12. Neither of those add to 1 though. There's 2 and negative 6, or negative 2 and 6. But again, I can see that there's no way to combine a 6 and a 2 to get a 1 of any kind. Okay? So my next possibility is 3 and negative 4, or negative 3 and 4. Now of those two, I can see that there might be a way to combine 4s and 3s to get a negative 1. And indeed, it looks like this factoring right here is going to give us that. 3 times negative 4 is negative 12, but 3 plus negative 4 is negative 1. So these are the factors I want, 3 and negative 4. I'm going to rewrite that middle term. So 4x squared plus 3x minus 4x, or plus a negative 4x, as we did in the above example, minus 3. Check it. Plus 3 and minus 4 is minus 1. So that looks right. Group in pairs. Remember, you can't throw a group after a negative sign. So you either have to change minus 4x to plus a negative 4x, or you have to, as a shortcut, just include that subtraction in your grouping symbol and think about it as a negative. Out of this first group, we can pull out an x. That's going to leave us with 4x plus 3. Out of our second group, because it's negative, we know we have to pull out a negative or a minus something. And notice that there is no common factor other than 1. But we have to pull out the negative 1 because we have to make that group positive. So by pulling out a negative 1, that's just going to change the sign of everything. So minus 4x becomes a positive 4x, and minus 3 becomes a plus 3. Which is good because now our groups match. And we've got 4x plus 3 multiplied to the group of what's left, which is x minus 1. All right, let's look at this example. 3a squared plus 2a minus 5. Multiply the first term and the last term with sign together. Okay? We've got negative 15. We want factors of negative 15 that add to give us our middle term, which is a positive 2. All right, we've got various combinations of 1 and 15, but I know that there's no way to combine a 1 and a 15 to get a 2. So I know that's not going to work. 2 doesn't go into 15, but 3 does. We've got 3 times negative 5, or negative 3 times positive 5. Can I combine either of those two with addition to get a positive 2? And the answer is yes. Negative 3 times 5 is negative 15, but negative 3 plus 5 is a positive 2. So I'm going to rewrite my middle term. Now I've got 3a squared minus 3a plus 5a minus 5. Negative 3a plus 5a is the same as plus 2a. Group in pairs. Out of that first group, I can pull a 3 and an a out, which leaves me with a minus 1. Out of that second group, I can pull a positive 5 out, which also leaves me with a minus 1. My groups now match, so I've got a minus 1 times the group of whatever is left, 3a plus 5. And there's our factored problem there. Okay, let's look at this problem. Multiply your positive 4 and your positive 9 together. That gives us a positive 36. We want factors of positive 36 that add to give our middle term, which is a negative 12. Okay, so we've got 1 and 36, which of course, no way you can combine 1 and 36 in any way to give us a positive 12. We've got 2 and 18, but 2 and 18, there's no way to combine those either to give us a 12 of any sort. So we might think about, say, 9 and 4. Well, 9 and 4, again, you can't combine a 9 and a 4 to get a 12. Eventually, though, we'll probably get to 6 times 6. Okay, now there are ways to combine a couple of 6s to get a 12. Notice that since it's a positive 36, our factors would either have to both be positive or both be negative to get a positive 36 when we multiply. Also note that if you take those two and you add them, that does give you negative 12. So we've got negative 6 and negative 6 is going to be the combination we're going to use. We've got 4y squared minus 6y minus 6y, or you can write plus negative 6y for both of those if you like that better, plus 9. Group in pairs. We're going to group the first two together. And for your second group, again, you either have to write plus a negative or you have to include that negative in your second group because you can't throw a group after a subtraction sign. Out of this first group, we can pull a 2 and a y, which leaves us with 2y, minus 6 divided by 2 is 3, and we pulled the y out. Out of the second group, because of that subtraction sign, we have to pull out a negative something. The common factor there is a 3, so pull out a minus 3, which leaves us with negative 6 divided by negative 3 is a positive 2, y, and 9 divided by negative 3 is minus 3. Groups match, so we've got 2y minus 3 times the group of what's left, also 2y minus 3 after you remove these groups. Now, this answer is fine. However, note that because those groups are exactly the same, you also could write that answer as 2y minus 3 quantity squared. Group times identical group is group squared. So that's another possibility for the form of that answer. Okay. So those are the ones we just did. There we go. Let's look at this problem. 12a squared plus 16ab minus 3b squared. Okay. The thing that bothers students on these two examples is now there's no longer just one variable. Notice that now there's a's and b's and then a combination of the two in the middle term. Okay? The method doesn't change any here. Okay? You're going to use the exact same technique. You're going to look at the first coefficient and the last coefficient, and you're going to multiply those two together, ignoring the variables as your first step. So multiply positive 12 to negative 3, and that gives you here negative 36. And like before, we want factors of negative 36 that add to give our middle term, which is positive 16. Now again, 36 will break down in a variety of ways. One way is 2 and 18. Now, one of those would have to be negative. You would agree with me that if the 2 was negative, then when you added these together, negative 2 plus 18, that would give us a positive 16. So just like before, we're going to take those factors and we're going to rewrite our middle term. Now, the only thing you have to be careful of here is you have to have your variable piece match the middle term. They've got to be like terms because you're not changing the problem, you're just rewriting it. So instead of writing plus 16ab, now we're writing minus 2ab plus 18ab for our middle term. Negative 2ab plus 18ab, those are like terms, so if you combine them, you'd get positive 16ab, which is the original problem. Like before, the first term doesn't change, and the last term does not change. And now you're right where you were before. You've got 4 terms. You're going to group in pairs. Okay, group in pairs. Factor out of each group. So we've got, out of our first group, we can pull out a 2 and an a. That leaves us with 6a minus b. Out of our second group, we've got a common factor of 3 and one of the b's. So we're going to take out a positive 3b, which leaves us with 6a minus b. Notice our groups match. So factor out the group. We've got 6a minus b times 2a plus 3b. And that's our answer. Okay, so let's do this example here. We've got positive 6 times positive 6 gives us a positive 36. And we want to break that down so that when we add factors together, we get a negative 13 when we add. Okay, 36. There's various combinations of 1 and 36 and 2 and 18. We've got 3 and 12. Now notice that looking at all of those pairs, none of those 3 can be combined in any way to give us any kind of 13. So we've also got 4 and 9. And there is a way to combine a 4 and a 9 to get some sort of 13. So we want to think about that in terms of sign. A positive 4 times a positive 9 is positive 36. But when you add those together, that is not equal to a negative 13. So I know that that possibility doesn't work. But I also have the double negative possibility, because negative times negative is still a positive 36, but negative plus negative gives us a negative 13. So those are our factors, negative 4 and negative 9. So we're going to rewrite the middle term. We've got negative 4, now xy. You want it to match whatever's up here. Negative 4xy minus 9xy, or plus a negative. Last term does not change. First term does not change. Group in pairs, making sure that if you did not originally write this as plus a negative, you've got to include that negative in your group or change it to plus a negative 9. Factor out your greatest common factor. We can pull a 2 and one of the x's out of our first group, which leaves us with 3x minus 2y. Out of our second group, because this is negative, we want to pull out a negative something. We can pull out a 3 and one of the y's, which leaves us with negative 9 divided by negative 3 is a positive 3. The x is still there. The y we took out. Positive 6 divided by negative 3 is negative 2. Notice each term changes sign when you factor out a negative. And we took one of the y's out, so we're still left with a y. Our groups now match. So factor out the group, 3x minus 2y, and multiply that to whatever's left when you factor that group out. And you've got 2x minus 3y, and that is your factored answer. Okay, so as always, when doing any kind of factoring problem, you always look for a greatest common factor as your first step if needed. Now, we didn't look for that in the previous examples because I knew that there weren't any. Okay? But now we're going to start looking at greatest common factor as our first step always. So notice in this top example, 4m squared plus 2m minus 6, there is a common factor of 2 we could pull out. So if you pull 2 out, you're left with 2m squared plus m minus 3. Now at this point, as always, take what you're left with after your greatest common factor and see if you can factor it further. So I'm going to pull it out to the side and try to factor it further. 2m squared plus m minus 3. We're going to find our product a times c, which is positive 2 times negative 3. That gives me negative 6. I'm interested in factorizations that when I add give me an understood positive 1. There's an understood positive 1 in front of that m. So with negative 6, there's various possibilities. One of the possibilities would be 3 times negative 2. 3 times negative 2 is negative 6, but 3 plus negative 2 is a positive 1. So as before, what I want to do is I want to rewrite that middle term, okay, and I'm going to bring that out to the side here. I've got 2m squared plus 3m minus 2m, 3 minus 2 is 1, minus 3. I rewrote my middle term. I'm now going to group in pairs. Make sure that you keep that negative sign in that group. Factor out of each group, and I'm going to bring this down right here. Out of that first group, I can factor an m out, which leaves me with 2m plus 3. Out of that second group, I don't have a common factor, but I have to pull out a negative 1 because I need to have that first term be positive. So that makes 2m plus 3 in that second group. Those two groups match. So we've got 2m plus 3 times what's left after you factor that group out. That's m minus 1. And that will go in for this. And so my final answer is 2, which I factored out in my first step, times the factored form of the group that's left, which is 2m plus 3 and m minus 1. All right, so let's look at this example right here. Okay. We'll do all the work under that blue line so we don't get confused. All right, out of this next problem, again, we're always looking for a greatest common factor first. So out of 35x cubed minus 60x squared minus 20x, we can see that we can pull out from the coefficients a 5, and we can also pull out one of those x's. Okay? So if you pull out a 5x, 35 divided by 5 is 7. We had 3 x's, we pulled out 1, that leaves us with 2, or x squared. Minus 60 divided by 5 is minus 12, and we only pulled one of the x's out, so we're still left with an x. Minus 20 divided by 5 is minus 4, and we pulled the x out, so the x is gone in that last term in that group. Okay, so now we're interested in factoring that term right there. So we're going to take 7 times negative 4, which gives us a negative 28. We want that when we add the factors to give us our middle term, which is negative 12. So 2 factors that multiply to give negative 28, but add to give us negative 12. Now you might run through all the possibilities there. One of the possibilities, though, is 2 times negative 14. 2 times negative 14 is negative 28, but when you add those factors instead of multiply, you do get minus 12. So those are our 2 factors. We're going to rewrite that middle term. And again, I'm just looking at the group for right now. So I've got 7x squared plus 2x minus 14x minus 4. Group in pairs. Factor out any greatest common factor. Out of that first group, I can pull out an x, which leaves me with 7x plus 2. Out of that second group, I have to factor out a negative, and I can pull out a 2. Factor out a negative 2, and you get a positive 7x plus 2 left in your group. Notice your groups match. You've got 7x plus 2 times the group of what's left, x minus 2. And then don't forget that greatest common factor that you factored out in your first step to be multiplied to the factored form of your group. And that is your final answer, 5x times the quantity 7x plus 2 times the quantity x minus 2. Finally, remember this method will also work for the easier types of trinomials too, x squared plus bx plus c, as long as you recognize that a is an understood 1. So if you really don't want to memorize 2 different methods, one for the easier type and another for the harder type, know that the method that we just talked about, where you rewrite the middle term, does work for all of the trinomials as long as you recognize that the easier type has an understood 1 out in front of the squared term. So just to prove that to you, if you really wanted to use this method for these as well, a times c would be 1 times 21, which is a positive 21. We want factors of positive 21 that add to give us our middle term, which is a positive 10. Okay. 7 times 3 seems to work perfectly. 7 times 3 is 21. 7 plus 3 is a positive 10. So using this method, we're going to take that middle term and we're going to rewrite it as a positive 7m plus 3m, and then the first term and the last term remain unchanged. Group in pairs, as we've been doing. Factor out of each group. Out of that first group, we can pull an m, which leaves us with m plus 7. Out of that second group, we can pull a 3, which leaves us with m plus 7. Our groups now match, and we've got m plus 7 times the group of what's left, m plus 3. And that is your factored answer. Doing this next problem, if you chose to use this method, you could. you've got an understood 1 as your a. So you've got 1 times negative 12 is negative 12. We want factors of negative 12 that will add to give us our middle term, which is an understood plus 1. Various combinations will give us a negative 12. One of them is 4 times negative 3. 4 times negative 3 is negative 12. 4 plus negative 3 is positive 1. So those are our factors. We're going to rewrite our middle term. So we've got y squared plus 4y minus 3y minus 12. Group in pairs. Either include that minus in your group or rewrite that as plus a negative 3y. Factor out of each group. We can pull a y out of this group, which leaves us with y plus 4. Out of the second group, we can pull a negative 3, leaving us with y plus 4. And we've got y plus 4, y minus 3 as our factored form of y squared plus y minus 12. This is the end of Module 11, Section 6.4 material. You should now complete the homework for Section 6.4 found in My Math Lab, and when you have successfully completed the above homework, proceed to the video for Module 11, Section 6.5.